The second lecture will be about the diagnosis of cases with signs of keratoconus, but without ectasia. These cases, we begin to call them pre-keratoconus. The definition of ectasia is a topotomographic representation of the corneal biomechanical failure. In my opinion, there is not keratoconus without ectasia. It must be ectasia to call it keratoconus, pellucid, keratoglobus, or ectasia post-surgical surgery. So there are three main features in keratoconus. Ectasia or protrusion that we are going to see in the best fit sphere by the lump formation at the center or by steepening or hyperprolaticity. Okay, and I compare our football ball, which is really a football ball, against the American football ball, which is not a ball, it's an egg. And gringos don't play with the feet, we call football. They play with the hand. So I always make fun of them when I say that their game should be called hand egg and not football. Okay, but the point is that the maximum best fit sphere is the difference of the cornea with the average curvature in 8 millimeters, which will be the best fit sphere of that surface. So we have, with the pentagon, you are used to use that, the Belling-Ambrosio display. But the Belling-Ambrosio display has the cutoff values of 7 and 16 microns, okay, and it modifies the best fit sphere, flattening the best fit sphere to produce a best fit sphere maximum larger. So this is probably because the pentagon aligns the data to the apex, and the apex is the most anterior point in the cornea. Okay, in the Galilei, the height of ectasia is measured by the BFS maximum, and with the regular maps, the best fit sphere maximum is the height of the mounting, and you can see that the cutoff values are very close to pentagon without the need to enhance any number. Okay, and this produces a good ROC curve for sensitivity and specificity, which means false negative and false positive. So even in front of Renato Ambrosio, who is my friend, and Professor Belling, I create courage, told them in the symposium, I am sorry, Professor Belling and Renato, we don't need the bad because we have the good. Okay, the Galilei optimized ocular display, and we don't want to be so proud. We don't call it God. Galilei optimized display. And this is to make fun because many people believe that the bad is the panacea and is enough to diagnose keratoconus or pre-keratoconus, as we are going to see now. So how we see the lump in Galilei? The Galilei, the numbers produce green at the center in 4 millimeters. And we begin to see the lump with what I call the fried egg pattern in the best fit sphere maps and the best fit toric asphetic maps. So this is, if you remember, the best dystrophy of the retina, the fried egg pattern. That if you see that, you are suspecting that there is a lump in that surface. Okay, for example, in this is not in the anterior, but is in the posterior surface. Okay, so let's report cases after we saw this bilateral symmetric toric with the rule steepening. And this was my first case. You can see that the Kmax is 4960 in the anterior minus 7.3, but there is not a lump here in any of the best fit sphere maps, no comma, and the pachymetry is with, you see the indices of asymmetry are completely normal, okay, it's normal pachymetry, all the maps, no ectasia, no Freyek pattern, okay, and this is the sister, younger sister, and it's actually worse than the first case. The first case is very interesting because it was the, how you say, stepmother or something like that, in marriage of my daughter. They are very close friends, so I discovered her for that reason. But the important thing of these cases, this is the first case, and you can see 11 years, I don't have maps before, but from 2017 to 2021, exactly the same, no changes, okay? And the worst case, the sister, from 2018 to 2022, also with 11 years of follow-up, exactly the same, no change, okay? So after this, I began to discover more cases. This is a 36 years old with 2 years, exactly the same. And this is a very interesting case, a girl that I began to see 6 years old, now just last year married, this lady, and at the beginning was only Placido, okay, but since I have the Galilei, she is exactly the same. And in that eye, because the anisometropy, she had almost 6 of a cylinder in that eye. I put 2 rings, 2 segments, 90 arc, 90 degrees arc, and now actually the astigmatism was inverted, okay, a little bit, but now she can use both eyes together. We reduce it tremendously, the anisometropy. So I put this in a group of Galilei, and I began to receive more cases from different places. Nobody will discuss this about keratoconus. This red will say with any other device keratoconus, but look at the pachymetry. It's very thick pachymetry, okay? And there is the beginning of a lump here, the Freyek pattern, but this case, after 5 years, is comparative here, perfectly green, no change, nothing happened in that cornea. Of course, if we avoid other risk factors external, like rubbing or allergic inflammation. This is in Ecuador from Dr. Sandra Largo, and in 2013 was diagnosed and had PRK. Okay, PRK 1 year less than 1 year later was +5, and I asked Dr. Largo about this last year, and she told me that it's remaining the same after the PRK, only for the cylinder. Okay, so it gave us a light about. I'm not courage. I don't have courage enough to do surgery in these cases yet, but there are people who is doing. This is a case from a children, but now with a thinner cornea, 480s, okay, from Chile, and this is from Peru with a thick cornea, but also, this Dr. Nancy Sandoval in Arequipa, south of Peru, more than is 2,500 meters of altitude, the city. And she began to have more and more cases like this, and at least 2 going to keratoconus. So we have to be careful with these cases. There is another case in Curitiba with surgery already, and is in evolution since last year with PRK, and there is another one in El Salvador, Central America, also with PRK, and is still in evolution. Doctor says they are stable. So perhaps we began to have a kind of keratoconus or prekeratoconus that in some cases we can do PRK safely. Okay, and how we explain this? Why I say that it's not keratoconus? Imagine an egg. A smudged egg. Okay, these corneas are toric, where the egg is smudged from top to the bottom, but they don't have the lump. They don't have what in Spanish we call chinchón, okay, the lump. I don't know how it's called. Tangusa. The cornea has not the tangusa. Okay, there is not biomechanically focal failure. So there's corneas, because they have the ectasia demonstrable, these cases will have Belin-Ambrosio negatives, not the red at the center. Okay, I would call them keratoconus type 1, and it's probably, at least in Latin America, the more frequent type of prekeratoconus. The other irregularity or feature keratoconus has is the asymmetry. Asymmetry is very important, okay? And asymmetry we used to see in the topographic maps. All you have anterior surface topography maps, but not the posterior. It's the same concept for the posterior surface, because I believe keratoconus begins in the back and not in the front. Okay, so and I want to point out that to measure asymmetry is not the same than to measure ectasia. Okay, to measure how tall is the Pisa tower in Pisa, we are not measuring how tilted it is. Are two completely different parameters. So we may have corneas asymmetric without ectasia with ablation in the anterior surface, or with ectasia. Okay, so ectasia or asymmetry can be measured with the Rabinovich index, or IS, or with the KPI, keratoconus prediction index, and keratoconus probability, or with the cone location and magnitude index, CLMI, from the anterior surface. Okay, CLMI and KPI has a very good ROC curve of statistics with very few false positive and false negative. These are two studies, okay, one in Colombia, one in Kuala Lumpur. But unfortunately, these indices are not good for evolution, progression of keratoconus, because grade 1 may have the same values of grade 4, okay? So, and Belin-Ambrosio display tells you nothing, absolutely nothing about asymmetry, because they don't, this display and this mathematics don't assess asymmetry. In the pentagon, the only index you have is the Rabinovich, the IS, which is maybe not enough. The best way probably to see the asymmetry of the surface is with the best fit toric aspheric maps. This is an ideal aspheric toric reference surface which is generated from the best fit sphere value at the center as 0 value. And the value we measure was called Craneman RC index in 2009. Okay, I presented this index in ACRS in Boston, ECRS in 2010 by posters. Nobody saw my posters, but that's for history. Okay, In 2010, I went to Cleveland Clinic with Ron Kruger group and fellows to teach Galilei there. And I found some people which were an intellectual sponge, and I will show you what happened. So the index is the difference between the more protruded point and the more depressed point in microns. And in keratoconus is very evident because this exactly will be the coma map in diopters. Okay, the yellow in the bottom, the blue at the top, showing you that the cornea is already sinusoid, like an S, depressed at the top and protruded at the go forward at the bottom. So David Desmaja and Marconi Santiago Glaucomelo were the fellows of Ron Kruger at that time. Professor Collin already passed away in Bordeaux, and now the present chairman of Bordeaux Keratoconus Center in France, David Taubeau, good friend, okay, because David is French, but now is working in Israel. And he found, when combining with the corneal volume, these incredible numbers for sensitivity and specificity. One problem with David was that he used a device and he didn't know that alignment of the data may change the index. He didn't put all the cases in the same alignment. In my point of view, this index would be much better if we align to the pupil or even to the white-to-white, which are more geometrical reference points, than to the Purkinje, which is visual and is affected by the kappa angle. So Zimmer decided not to implant the display they created with this decision tree because they used the same characteristics of CLMI X and they didn't find a good result. The CLMI X is another index that Galilei has that combines curvature, anterior and posterior, best fit sphere pachymetry. And you can see these incredible numbers, this is published, okay, of sensitivity and specificity, which is much more better numbers than the Belling-Ambrosio display. And this is a case with no keratoconus, and this is a case with keratoconus. We don't have time to go forward explaining more of that. So we go to the next pre-keratoconus type that I will show you this time. And this is the asymmetric corneas. Canelopoulos produced a lot of cross-linking in cases that he believes are keratoconus, but I told him once, maybe they are not keratoconus because you didn't see the posterior surface. Okay, you are only observing by curvature map anterior, and in this we have a very clear asymmetry anterior and posterior. Okay, but you can see completely green here in the best fit sphere and best fit toric and spheric maps. So there are no ectasia, and the pachymetry is very good. Excuse me. Okay. And so this is another very clear case about this. This will be classified as keratoconus by curvature, but and even by pachymetry because it has a thin cornea. But in best fit sphere and best fit toric maps, we don't have the pattern of ectasia. So there is no ectasia, normal, completely normal elevation. Madame, please. Okay, but these cases are very frequent in Middle East. When I was in Lebanon with Shari Awad, and with other friends when I was in Israel or in Amman, I was able to see a lot of these cases, very thin corneas. Sorry, this is another case. The asymmetric, when you see protrusion and the fried egg pattern in the posterior, you can miss this because you say this is only asymmetry in the anterior surface. You must see the posterior curvature map and the posterior elevation map. You can see the asymmetry we have here. So we all know that these cases are going to postoperative ectasia is one of the most important risk factors for ectasia after refractive surgery. So this is keratoconus grade 1 with ectasia only at the posterior surface. This is another one with very thick cornea. However, we know that this has faster thickness progression, okay, despite the thick, okay, and the ectasia is only at the posterior surface. Grade 1 without anterior ectasia and asymmetry, okay, we find even in thicker corneas like this too. This is with the Galilei G1. And the three main features we have is the central thinning in comparison with the periphery. I was confused, sorry. This is the kind of cases, very thin corneas that are usual and very frequent to find in Middle East, okay? And we know now that the progression of pachymetry not always is symmetric. We may have asymmetric, and when we have more than 10 steps in the Galilei with 20 microns, we have more than 200 microns between the thinnest point and this row here at 9 millimeters. So it's very easy to know when we have a faster progression, because if we have, for example, 480 here, to say a number, and we have numbers here more than 780, we already have 200 microns difference. So is in only a view, a glance, we know that there is a faster progression of pachymetry, at least in 1 or 2 quadrants. Okay, this is shown by the graphics of the Belling-Ambrosio display. We know that when the second half of the graph goes steeper is because there is a faster progression, but it is interpretation also. Now, we must differentiate corneas that are uniformly thin and corneas that were thinned at center because they were protruded, okay? And we use the 500 as our Caras value for the yellow in the scale. This is a normal cornea, and you can see in this prototype that is already changed by Sharia Watt from Lebanon, okay? And now the new display that is probably going to be launched soon this year is showing maps of 3, 6, and 10 millimeters. Okay, because there is not only the graphic, but there is a map of progression of pachymetry. Okay, and this is how point to point the pachymetry progress from the center to the periphery. And you can see something, I don't know if this was purpose or not, but we observe it, that the graphic ends in the vertical, not in the horizontal. Okay, and this is also a thick cornea pattern and a false negative, because if you see only the graphic of pentagon, this will accomplish all the second half steeper. And I know very well this cornea. This is my secretary, and she is my guinea pig for everything with the devices. So she has not keratoconus. It's a false positive with this method. Okay, but we have also normal corneas with 506 ending in the vertical, and 504, but ending in the horizontal. Okay, and the map ends in yellow and orange and red, and the periphery. The same with this too. Okay, so actually with more thinness point than the normal case here, and these are keratoconus, a faster progression of pachymetry. Okay, this is the best way now to distinguish. So we have cases like this. We have a cornea, okay, with this thin cornea without ectasia. You can see that the progression is less than 200 microns, despite this cornea has 454, and there are no ectasia here, no lump, and the maps of curvature are even orange. Okay, there is a peripheral flattening, but there is a thin cornea without ectasia. Another case without ectasia with 502. Okay, if you see only the curvature maps, you will see practically normal corneas. And another one without ectasia and CLMIX 0, despite it has 449 of thinness point. And this is perhaps beginning the ectasia. We begin to see the yellow and the Galilei coming to the center. Okay, and another case here, because there is with normal progression, okay, or this is with a steeper thickness progression. Okay, so perhaps the combination of features or parameters produce these cases that may go easier to keratoconus. Of course, these corneas, after rubbing or inflammation, we have in all this area more sunlight, and despite there is more UV, there are more red eyes also. Okay, and there is a theory, we produce it, about environmental pressure. In summer of northern hemisphere, all the Middle East become with very low environmental pressure because the trading winds, which produce even in India the monsoons, for example. So the heat air from the top goes down, and cold air and produce this kind of winds, reducing the environmental or barometric pressure. We began to study this after we discovered that in highlands, like at the Andes, all the people who live above 2,000 meters of altitude have a lot more prevalence of keratoconus than people who live in the coast at sea level, despite the same race, the same ethnia, and everything. So maybe environmental pressure. I would like to know in the future what is the prevalence here in Algeria and what is the environmental pressure in different times of the year, because we are trying to correlate this around the world. So when we combine different parameters, in this case asymmetry and a steeper progression, we begin to have the possibility to get keratoconus. So there is not keratoconus without ectasia, but there is a steepening, there is asymmetry, there is thinning, and there is peripheral flattening without ectasia. So not everything what is brilliant is gold. Not everything what is red in these maps is keratoconus. So in conclusion, we found corneas with common signs of keratoconus before ectasia is formed, and I call these corneas as pre-keratoconus. These are the values we use now for all the parameters, and this, if you want to take a photo, are links of papers. Yeah, I knew that you are going to record this. So, okay, you tell me when I go forward. Okay? And these are links of papers. I had a mistake in my life during the last 14 years. I was consultant of Zimmer. I produced very few peer-reviewed papers, but I had more than 15 chapters of books in Spanish, Portuguese, and English. So there's some of my papers and lectures that you can go by Dropbox link. Muito obrigado. Shukran. Merci beaucoup.